SFB Addict here, going to do a little video on partitioning for a GNU or GNU Linux install. So, when it comes to installing Linux on your computer, one of the more often asked questions is how to do the partitions, or what's the best way to do the partitions. Well, typically you end up with Windows and Linux for a dual boot. Most installers give you an option to take over the drive or to share it with Windows and then make decisions on swap and where to place home all on its own. That, or there is a manual option, and this is where most users are completely lost as to what to do. So let's take a look at what partitions actually are. Well, basically they're divisions of a hard drive. There are primary partitions and extended partitions. So what's the difference between the two? Well, a primary partition is one that is supposed to be where an operating system can boot from, and you can only have 4 of them. And an extended partition is in addition to a primary partition. In reality, most drives will have one primary and then one extended partition in which other logical partitions are made. And the reason they only have the one primary is because they only have one operating system to boot. And here's a quick little picture of a hard disk platter with 3 divisions for C drive, D drive, and E drive. Just a visual example. While extended partitions aren't meant to be booted from, Linux can indeed boot from an extended partition. Windows probably can as well, but most documentation on partitions pretend that no operating system does by convention. I mean, like, who's going to have more than one operating system on a computer? Who will ever need more than 64K of RAM? So, if you want an extended partition, you can only have at most 3 primary partitions, as one is used for the extended partition. An extended partition can be further subdivided, and these are labeled logical partitions to avoid the confusion of referring to them as partitions of partitions, or partitions of the extended partition. And here's a couple visual examples. So here we see a C drive as a primary drive. This is the entire hard drive, and then there's a extended partition here. So 2 gigs is C drive, 2 gigs is the extended partition, and in the extended partition we have 3 logical drives, D, E, and F. Over here we have another visual example where we have 3 primary partitions and then 1 extended partition, and in that 1 extended partition there are 2 logical drives. Well, what about the master boot record? What partition is that in? Well, the master boot record basically is a file that contains the physical locations of all of the partitions. So the master boot record actually precedes the first partition on a drive. Can't drives have more than 4 partitions now? Yes, older machines use master boot records, or master boot records plus GUID. Modern systems use something called GPT. GPT is a replacement for master boot records, as master boot records only supported up to 2 terabytes of a hard drive in size, and it could only have 4 primary partitions. GUID was the previous expansion of master boot records for EFI and went up to 128 partitions. The new GPT supports many more partitions than that. So doesn't Grub 2 replace the master boot record? Yes, Grub 2 goes into the master boot record area, but if you are dual booting, it preserves the original instructions for booting the non-Linux operating system. It's there as an option, so you can boot either Linux or you can boot Windows. It is actually possible to keep the master boot record and not use Grub 2 at all, and use EasyBCD software instead to create the option for booting Linux in the master boot record. But this is more complicated than just using Grub 2. So most websites or instructions for setting up Linux with a dual boot for Windows don't even mention it. Here's a video by Matthew Moore where he's showing what it looks like when you actually do use the EasyBCD route to create an option for Linux. You get a box or a menu item for Windows and another one for Linux. So pretty okay video, you should check it out. And here is the difference between the two. So up top here we have the master boot record, which will then go to Windows and have an option for Grub. So it's got the option for Windows and it's got the option for Linux. So this is the setup that Matthew is describing in his video. Down below is typically what most Linux setups end up using, where the master boot record is replaced by Grub 2, and then it has the Windows loader for loading Windows, and then there's an option for Linux and its additional information, partitions, swap, home, etc. So, how to partition the drive? How are Windows drives already partitioned? Old Windows 95, 98, ME, and XP, it would just be the master boot record and one partition, basically. That kind of started changing with XP, but I put it here on the slide as Windows 7 onward. Windows 7 onward, they had the master boot record, the operating system of Windows, a recovery partition, a reinstallation partition, and a partition of repair tools, or recovery tools. These partitions are often hidden from the operating system and have no drive labels. Some partitions may even be upsell trial software. This, of course, just makes it more difficult to know what is what if they aren't clearly labeled. And here's an example of that. So we have the C drive, and then we have a bunch of other partitions which really aren't labeled with a drive volume, but over here you can sometimes figure out what they are by what they say. So this one does say recovery partition, that's 300 megabytes. And then you got EFI system partition of 100 megabytes, but then you got 23 gigabytes, and then you got another one here for 60 gigabytes, and then you got another one here for almost 4 gigabytes, and then you got another one here that's half a gig, or 596 gigabytes. And then you have 98 gigabytes here, which is NTFS, which is boot, page, crash, dump, and primary. Well, my guess is that most people aren't going to be able to figure out what the hell's what here. The biggest partition is usually C drive, or where Windows lives, or sometimes there will be an empty storage partition or even another drive that might be bigger. Most Linux installers ignore these extra partitions and just shrink the Windows C drive via a slider, or they stick Linux in there. Linux is tiny in comparison to bloated Windows. And here's an example of one of the installers where it lets you grab a slider and move it back and forth to size the hard drive for how much of it's going to be Windows and how much of it is going to be Ubuntu or Linux. So as you can see, it says allocate by dragging the divider below. It says 3 smaller partitions are hidden. Use the advanced partitioning tool for more control. Okay, so what are the typical partitions for Linux? Well, excluding Windows, if it's just going to be a pure Linux machine, the smallest would be the master boot record and then Linux. Swap isn't necessary if you have a large amount of RAM. Typically, on most systems, it is master boot record, Linux, and a swap. What is recommended is that you have your master boot record, the Linux partition, a swap partition, and then a separate home partition. Of course, master boot record really isn't specified in most images as a partition, as it is before the first partition. But if you want, you can create a partition for it. Now, what home is really isn't part of what this video is about, but basically home is where Linux users have the folder that is that particular user. So if there's 5 users on a system, there'll be 5 separate folders that is their username, and inside that folder will be all of their personal Word documents, text files, pictures, images, music files, movies, that sort of thing. Okay, so here the top picture is an example of a pure Linux system. So you have your swap space, and swap is using the hard drive space as RAM. And then we have a home partition, and then we have a partition for the actual Linux install. So here it is a 74 gigabyte drive, and you'll notice that only 20 gigabytes of it is being set aside for Linux. And if you actually look at it, it's only using about 10 gigabytes of that 20. And here you have home, which is 50 gigabytes. So you'll notice that the live CD install application at the bottom asks where to put the bootloader. So that's down here. Gparted itself doesn't make a bootloader entry. So up here you don't see anything that's saying bootloader. And device for bootloader installation right here. Now this is the install program. So when you actually run the install program to install Linux, this asks you where to put the bootloader. Gparted isn't what makes the install. Gparted just lets you divvy up the hard drive the way you wanted to divvy it up. Now some installers, like this one here, this is essentially Gparted, but it's not as easy to understand for some people. Now you can do everything that you can do here in Gparted in this installation program by using the new partition table add and change, if you know what you're doing. So for some people, they prefer to use Gparted because it's a little bit easier to understand. Complications. Sometimes Windows will not shut down properly and it locks the hard drive, preventing you from doing partitioning. Shutting down Windows while holding the Shift key helps resolve this. Sometimes users go into standby instead of actually shutting the computer down, thus locking the drive. So be sure to actually shut down, not go into standby. Sometimes a Windows partition will also span more than one hard drive. These should be shrunk using the Windows partitioning tool. Otherwise, you may corrupt your Windows installation. So the difference between Gparted tools and the Windows partitioning tools? Well, Windows labels drives IDE0, IDE1, etc., or HD0, HD1, HD2, and partitions as HD0, comma, and then the number, HD0, comma, and then the number of the partition. The Gparted tool labels each drive SDA, SDB, SDC, and the partitions on the drives as SDA1, SDA2, SDA3, SDA4, etc., or SDB, 1, SDB2, SDB3, etc., or SDC1, SDC2, etc. Also make note, Gparted does not install Linux, it just modifies the partitions. To actually install Linux, you need to run the install program. So, in the Windows tool, you see each drive graphically, one under the next. So you see disk 0 and disk 1, and then you would see disk 2, disk 3. In Gparted, you see only one drive at a time, and there is a selector to change to another drive. So this one is SDB. You do not get down below anything that is on SDA or anything that is on a third drive, SDC, etc. All you see is SDB. This ensures that you don't think you have one drive selected when in reality you have another drive selected. What you select in the drop-down is what you are performing the operations on. So swap and the live CD. If you booted the live CD to test Linux, to try it before installing, and then you go to use Gparted, you might have an issue. That's because you need to unmount swap as it was mounted when you selected try instead of going directly to install. In Gparted, you need to right-click on swap and select unmount. So swap would be usually it's red. It's listed in the thing as swap. But you right-click and you select swap off to unmount. Swap. Partitioning. The Linux operating system is designated by a slash, where grub 2 goes by boot, and if home is a separate partition, by /home/, and swap by swap. The Linux operating system partition is going to be a format like ext2, 3, or 4. You can look up online the benefits and the drawbacks of each. Windows will be FAT32 or NTFS. Linux can see and read the Windows drives just fine, but Windows will need some software installed to read Linux partitions if you're going to dual boot and move files back and forth between the two of them. You can just make your home NTFS if you want. There are encryption implications to this, and you can read up on the benefits and the drawbacks of making home NTFS. So, two examples here. In this first pick, we will have two partitions, one primary and one extended. In the extended, we will have three logical partitions: Linux, home, and a share. So you have SDA, you have SDA1, SDA5, 6, and 7. So inside SDA2 is SDA5, 6, and 7. So the first one is your primary partition. It has got Windows on it. And then you have an extended partition containing these three logical drives. And those three logical drives are /, which is the actual root or the actual Linux installation. The next one down is /home. That's where all your movies and pictures and documents and music and all that's going to be. And then this one here is just labeled share. So that's just basically a blank drive that is formatted as NTFS so that you can, for instance, without having to install software in Windows, you can, while you're in Linux, move a file from home into share, and then when you reboot and go into Windows, Windows can see that file in share. And the second pick is three primary partitions and one extended. In the extended, you have three logicals: Linux, home, and swap. So as you can see, things start to get looking a little bit more complicated. So up here we have a FAT16 and two NTFSs, and you'll notice that it's SDA1, 2, and 3. And then you have an SDA4, which is the extended drive. And then inside the extended drive, you have SDA5, 6, and 7. And again, the SDA5 is root, which is your Linux install files. SDA6 is home. and SDA7 is a Linux swap of 2 gigabytes. And then you have some unallocated space. So I hope this was helpful in explaining what partitions are and how to perform partitions using Gparted to set up the partitions the way you want them. Have fun computing.